This is the screencast for section 4.3, example 5. All right, so let's find the following without a calculator. Emphasis on without a calculator. Hint, 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 for possible upcoming tests. Okay, the sine of negative 210 degrees. Well, first of all, I got to plot that on the coordinate plane, put that in standard position. So my initial ray is going to be on the positive x-axis. Negative 210 degrees. Well, negative 180 is going to go clockwise to the negative x-axis. Then another 30 degrees is going to be negative 210. That was a little curvy, but that's okay. So this is negative 210 degrees, which means my little reference angle here is 30 degrees. So I have a 30, 60, 90 that I can use as my reference. My height here is going to be 1, my hypotenuse is going to be 2, and my adjacent side is going to be negative square root 3. Again, negative because it's on the left of the y-axis. This is specifically asking me for the sine of 210 degrees, so the negative. So the sine of negative 210 degrees is going to be the opposite over hypotenuse. So that would be positive 1/2. This one was not negative because the height or the y-coordinate was positive and the hypotenuse was positive. Now parts B and C, we're flipping back into radian mode, which is what you should be focusing on. We're going to do very few of these in degrees. Most of them are in radians. 5 pi over 3. Well, let's see. 5 pi over 3. Put my initial ray on my positive x-axis. 5 pi over 3, well 3/3 is a whole, so a whole pi would be over here. And then we've got 2 more thirds, so not 1/3 but 2/3 is going to be right there. So this is the angle 5 pi over 3, which means I can look at one more pi over 3, this little pi over 3 down here, which if you remember is 60 degrees. So again we have a 30, 60, 90. The reason I got pi over 3, 6/3 is your full 2 pi, so we're 1/3 short of your 6/3 because you've only got 5 of them. So now I can use my, again, 30, 60, 90. So my hypotenuse is 2. My opposite side is going to be, let's see, negative square root 3, and then the adjacent side is going to be positive 1. This is asking for the tangent of 5 pi over 3. Tangent is opposite over adjacent, so that would be just negative square root 3. Part C is asking for the secant of negative 3 pi over 4. Okay, so negative 3 pi over 4 is not 4/4, not a whole pi yet, but negative 3/4 pi. So that's going to cut halfway through quadrant 3. So this is my negative 3 pi over 4 angle, which means I have a reference angle here of 1/4 left, pi over 4, to get me to my pi, my negative pi angle. So if I use a reference angle of pi over 4, that's a 45, 45, 90. So I can use square root 2. Let's see, the adjacent side is going to be negative 1, and the opposite side is also going to be negative 1, because this point is in quadrant 3, so it's like this point on the terminal ray was negative 1, negative 1. So it's fine. It's asking me for the secant of negative 3 pi over 4. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. So square root 2 over negative 1, so negative square root 2. The now try problem number 29 is asking for the sine of 13 pi over 6. Well, 12 pi over 6 is 2 pi. So this one's going even past 2 pi. It's going to go all the way around and another pi over 6. So instead of 12/6, 2 pi, a full circle, it's doing 12/6 and another 6, 13/6. So I have a little reference angle here of pi over 6. This whole big angle is 13 pi over 6. This little guy that we're going to use is pi over 6. So I'm going to draw my reference angle. Now pi over 6, if you remember, is 30 degrees. So again, I've got a 30, 60, 90. So the opposite side is going to be positive 1. The adjacent side is going to be positive square root 3, and the hypotenuse is positive 2, so we have all positives now. That's good. It's in quadrant 1. That makes sense. And then 13 pi over 6, because quadrant 1, the x and y coordinates are all positive. So the sine of 13 pi over 6, okay, sine is opposite over hypotenuse, so this would be 1/2.